Good morning to all present here. I'm Ramya Devi, working as Assistant Professor in SNS College of Engineering. Today I'm going to share a small article regarding unsupervised learning. Unsupervised learning is a machine learning technique that analyzes unlabeled data to find patterns and relationships. It's a key part of machine learning. So how it works? Unsupervised learning doesn't require labeled data. It can handle large amounts of data. It can reduce data into simpler forms without losing important patterns. It can find patterns and relationships that were previously unknown. So it can help you understand your data more deeply, and also it can help you reveal meaningful trends and groupings. It can help you discover patterns and information that was previously undetected. So examples of unsupervised learning includes anomaly detection, detects aberrant patterns or trends in data, and dimensionality reduction, analyzes unlabeled data, and DB scan finds group of data points that are similar to each other. And also the most important is association rule mining, identifies frequent patterns, correlations, associations, causal structures within certain data sets. So, unsupervised learning is a framework in machine learning where, in contrast to supervised learning, patterns exclusively from unlabeled data. Other frameworks in the spectrum of supervisions include weak or semi supervision, where a small portion of the data is tagged and self supervision. So it also includes clustering techniques are unsupervised in the sense that the data scientist does not determine in advance the labels to apply to the clusters. The structure of the data describes the objects of interest and determines how best to group the objects. Clustering is a method often used to exploratory analysis of the data. Clustering, there are no predictions made. Rather, clustering methods find the similarities between objects according to the object attributes and group the similar objects into clusters. Clustering techniques are utilized in marketing economics and various branches of science. So there are primarily two categories of clustering. One is hierarchical clustering and the other one is partitioning clustering. Hierarchical clustering is further subdivided into agglomerative clustering and divisive clustering. So partitioning clustering is further subdivided into k-means clustering and fuzzy c-means clustering. So k-means clustering, given a collection of objects, each with n measurable attributes and a chosen value k of the number of clusters, the algorithm identifies the k clusters of objects based on the object's proximity to the centers of the k groups. The algorithm is iterative within the centers adjusted to the mean of each cluster's n-dimensional vector of attributes. K-means is a centroid-based algorithm or a distance-based algorithm where we calculate the distances to assign a point to a cluster. In k-means, each cluster is associated with a centroid. The main objective of the k-means algorithm is to minimize the sum of distances between the points and the respective cluster centroid. So k-means algorithm, how it works? We have to choose the value of k, that is a number of clusters and the initial guesses for the centroids, and we have to compute the distance from each data point to each centroid and assign each point to the closest centroid. And also we have to compute the centroid of each newly defined cluster from step 2. Repeat steps 2 and 3 until the algorithm converges and no changes occur. Stopping criteria for k-means clustering. There are essentially three stopping criteria that can be adopted to stop the k-means algorithm. Centroids of newly formed clusters do not change. Points remain in the same cluster. Maximum number of iterations are reached. And also distance measure. The distance measure determines the similarities between two elements and influences the shape of clusters. K-means clustering supports various kinds of distances such as Euclidean distance measure, Manhattan distance measure, a square Euclidean distance measure, and cosine distance measure. So, determining the number of clusters. The value of k can be chosen based on a reasonable guess or some predefined requirement. However, even then, it would be good to know how much better or worse having k cluster versus k minus 1 or k plus 1 clusters would be in explaining the structure of the data. Next, a heuristic using the within the sum of squares metric is examined to determine a reasonably optimal value of k. In other words, WSS is the sum of squares of the distances between each data point and the closest centroid. The term indicates the closest centroid that is associated with the ith point. If the points are relatively close to their respective centroids, the WSS is relatively small. So the applications of k-means clustering. Some specific applications of k-means are image processing, medical, and customer segmentation.